problem? Well, let's start with the simple one, if there is such a thing. 6x to the fourth y over 21xy to the third times 7x squared y squared over 3x cubed y squared. This is simple compared to what we've been talking about in a bit here. Just remember, and it's not such an important thing on this one as it will be for the other ones, that in order to cross out things, okay, they need to be factors, okay? You need to have factors to cross cancel. Okay, you have to have factors, in which case all of these really are factors. You could write this whole thing on top and then all on the bottom and do it, but let's just look and see what crosses off here. Number-wise, the 3 crosses off with the 6 to leave you a 2 up there, right? 3 goes in 6 twice. The 7 crosses off with the 21 to give you a 3 on the bottom, correct? And again, now it's just a matter of counting up how many x's and whatever crosses off. This x will cross off with one of the 4 x's up here, which will leave you with an x to the third. Are you with me on that? Because there's 1 x, 4 of them are up there. But then you've got 3 x's down here, and those will cross off with those 3 x's you still had left up there.
Wait,
Let's go back. Just take a look here.
we're just randomly doing any.
Well, I'm just looking at it. Yeah, you don't have to pick. I mean, x's will cross off with x's, bottom x's with top x's. And I could have done, I could do this with this. It doesn't really matter in the end. And maybe it'd help if you multiplied all this and put it on top over this, but there's no sense in doing that when you're just going to cross them out anyways. For example, 2y squared, Mary, they're gone, because one top, one bottom crosses off. You have x to the third here, and an x to the fourth there. So those all go away, and you're left with 1 left over here, correct? Because there were 3 down there and there were 4 up there. Then this 1 and that 1 cross off, so there's no x's left over there. You've got 1y here and 3 down there, so that crosses off and you're left with a y squared on the bottom. Now, there's really nothing left to cross off, so now you just kind of remultiply. You have a 2 left with an x squared on top, and you have a 3 with a y squared on the bottom. The most difficult part about this is just staying organized and not being so messy that you can't tell what you've had or what you've done or what you're going through there. Didn't have to be in that order. I could have crossed off this x cubed with that x squared. You're still going to end up with kind of the same thing in the end. This, by the way, is just a generic problem, but not a tougher one. Here's where they get a little more difficult. Check this one out. Here's this what separates the proverbial men from the boys, as they say in the mathematical world. 9 over 3x minus 15 times x, I'm sorry if I'm boring something back there, 2x minus 15. I'm doing the best I can here. Okay, here is where you have to understand, children. First of all, I'm going to make this a fraction by putting it over 1. Okay, I cannot just randomly take this 3 and cross it off with that 9 because, like I said before, things have to be factors. And because this 3x is tied in with this minus sign to this 15, the only way right now, as it stands right now, for anything on this bottom to cross off, there would have to be another 3x minus 15 up on top somewhere as a factor. Okay? So right now, as it stands, I can't do anything with this. But if I can factor it down and then look for common factors that work. For example, what can I take out of 3x minus 15? I can factor out a 3, And when I do, I get left with x minus 5. Yikes. Yeah, we'll take care of that. Okay. Now, children, since these are factors, now I can cross this 3 off if I wanted to with this 9. Okay, now that this is a factor by itself, I can say, okay, 3 goes into 3 once, 3 goes into 9, 3 times. The only way for x minus 5 to cross off with something would be if there was a factor x minus 5 up here, which maybe there's going to be because I can factor a trinomial. And this is kind of a hint as to what that trinomial might give you. What can I factor x squared minus 2x minus 15 into? Well, what times what gives me negative 15 added together gives me negative 2. How about a minus 5 times a positive 3? Now, since they're factors, they're in parentheses, I can cross off this x minus 5 with that x minus 5. Nothing is left to cross off anymore. This is gone because I factored it down. Now I'm left with a 3 times an x plus 3 on top. And I'm going to say that the book probably wants you to remultiply that as your answer. 3x plus 9 is the answer to that problem. But again, let me reemphasize, you have to have them as factors. If they're in parentheses, that's fine. You can put a parenthesis around this and say, oh, did I have a 3x minus 15 up there? No, so I couldn't do it. No, I factor it. Kylie, how?
Well, I was gonna say, like, I'm gonna know how we did it the other time, but I was thinking that was just exponents, like how we did other things at the time.
Right, and those were all multiplication. Everything on that last problem was all multiplication. There were no addition, subtraction signs anywhere from that. That was all, everything was times itself. When you get addition, subtraction signs, then things start going a little willy-nilly haywire. Okay, with that being said, let's look at this one.
You wanna get harder?
Oh, that was just a piece of cake one. X squared plus 4x plus 3 over x squared divided by x plus 3 over x. No, this is dramatic poetry.
I just saw a lot of people write.
What does one notice about this problem?
Division sign.
There's an X.
It's a division sign. So the first step when you have a division problem is you need to make it a multiplication problem by doing what? Since we've done it since 5th grade, Lizzie? No. You need to flip and multiply by the second fraction. So you need to change this right away to x squared plus 4x plus 3 over x squared times, just flip this over x plus 3. And I probably should use a big old dot there instead of a times sign, because then it starts looking like an x and everything goes crazy. And nobody mentioned that I wasn't using the brush. I think nobody probably noticed. Okay, now here, I mean, I can cross the x and the x squared and do that right now, but the only way to get x plus 3 to cross off of something is if there ends up being an x plus 3 factor up here. I just can't take this 3 and that 3 and cross them off. Got that? I just can't pull this out of this little addition problem and put it up there. So the first thing really you want to do is factor. Before you do anything, factor everything as much as you can. And the first factor we do is this trinomial. I'm going to break it into what? X plus 3 times x plus 1. You feel free to always put that in parentheses. That's fine, because you could always put a 1 in front of it. And then you can just cross off as it would be like right now. This x plus 3 crosses off with this x plus 3. This x will cross off with one of the two x's, just to leave you with an x down there. And your answer will be x plus 1 over x. Why can't I cross this x off with that x? Because it's not factors. The only way x plus 1 crosses off is if there be an x plus 1 on the bottom.
Is that considered hard?
A hard one? No. I don't know, they don't really give you any hard ones, they give you pretty much. Here, let me give you one here, how about this one? How about 9r squared minus 12r over 27 divided by 3r minus 4. And they have this in parentheses, which I'm sure it could be. Go ahead, have at it. Where it says, lead them,
3r over 27.
3r over 27.
I got it.
Alright, so you put this over 1, your first step is to make it a multiplication problem, 9r squared minus 12r over 27 times 1 over 3r minus 4, correct? The only way to get this to cross off is if there's a 3r minus 4 up here, and we hope that that might be the case. We take a, how about a 3r out, and you're left with 3r minus 4. Oh, look at that, ain't that handy. And notice also, these are still factors of each other, 3 times r times that. This crosses off, 3 goes into 3 once, and the 27 9 times. You're left with just an r on top and a 9 on the bottom. R9. That's all you can do.